Okay, good morning. Today we will continue our lesson and we are talking about the conjugates. What's the meaning of conjugates? Conjugates that if I have two terms like or two radical terms like square root of 3 and square root of 5. If you add a plus sign between them and if you add a minus sign between them, they told me that the sum and the difference of two terms, we call them conjugates. Conjugates is the sum and the difference, are the sum and the difference of two same terms, like square root of 3 and square root of 5. Once it can be added and once it's subtracted. So, and the product of them, so this is, for that, this is the meaning or the definition of conjugates. You have two terms, square root of 3 and the square root of 5. They are the same. Okay, they can be added and can be subtracted. Like as an example, if you say 1 and 4 is like 1 plus 4 and 1 minus 4, the same numbers, but they can be added and they can be, or it can be added and can be subtracted. Another example, like if you have A and B, but one is added and one is subtracted. So you have A plus B and A minus B. Here is also we have a radical expression. The conjugates that I have two terms, these two terms, they are added and subtracted. Now, then the product of the conjugates is like if you multiply square root of 3 times square root of 3, like use the FOIL way or the table, like multiplying the square root of 3 times the square root of 3. Then square root of 3 times negative square root of 5. Then square root of 5 times square root of 3. Then square root of 5 times negative square root of 5. They told me that the product of them, if you multiply them, it will be square root of 3 squared minus square root of 5 squared. Without this complicated way of multiplication, it's only take the first number, square it, minus the second number, and square it. Like, do you remember when we said if we have x minus 2 times x plus 2, what we call this type of product?
Sum of difference.
Exactly. It is a difference. So what we have to do, we take the first number, square it, minus the square of the second number, which is 4. So it will be x squared minus 4. Here also, if we have radical expressions such as a and b, square root of a, square root of b, and we have plus sign here and we have minus sign here. These two pair of sum and difference, we call them conjugates. These are conjugates. Now, the product of them, you take the square root of a first, this one. Okay. You take the square root of a, you square it, minus the square root of b, and then you square it. Then a squared cancel the square root, you have a, and squared cancel the square root, you have b. So the answer will be a minus b.
Miss, I have a question.
Yes.
For example, instead of A we have 5, and instead of B we have 10. We're gonna root them, or we will remove the root and put them as they are.
Right, okay, I will make your example now. But here, as we see, but before Huda, please, as you see here, since they are the same, and we put, and here you have to do the same. You take the square of the first term minus the square of the second term. Yeah, now let's see. Huda says if you have square root of 10, like this, minus square root of 5, and you multiply them by square root of 10 plus square root of 5. Is it like this?
Yes.
Okay, so what we have to do here, as I told you, we have two terms, they are the same. One is minus and one is plus, so they are conjugates. Since they are conjugates, the product of them, I will take the first term and then I square it minus the second term. Then squared cancel the square root, so we have said it is 10, minus squared cancel the square root, so we have only 5. So we say 10 minus 5, which is 5. Right. Now, if you
Okay,
have,
Miss. Thank you.
if you have a square root of 10 minus the square root of 7, multiplied by square root of 10 minus square root of 7. Is this a conjugate?
No, because
No,
two
because there's no plus and minus.
Exactly. They are not added and subtracted. Thank you. Now, if you have a square root of 10 minus square root of 8, as an example, times square root of 10 plus square root of 7. Is this conjugate?
No. No, because
Yes.
there's two different numbers.
Exactly. They are not the
Yes.
same. Thank you so much. So this is the definition of conjugate. Now, when we use conjugates, we use it to simplify a quotient whose denominator is a sum or a difference of radicals. Let's see this example here. Let's add this number here. Here we have 10 over square root of 7 minus square root of 2. As you see here, we have a radicals in the denominator. And if we have radicals in the denominator, we cannot, this is not a simplified one. In the previous lesson, when you have 10 over square root of 7 only, we rationalize the denominator by multiplying by square root of 7 times square root of 7. Did you remember? Then after that, we said the denominator square root of 7 times square root of 7 is 7, and 10 times square root of 7, it will be 10 square root of 7. In this way, we call the way which we call it rationalize the denominator, we cancel the square root in the denominator. But look at problem 4 here. In problem 4, we have 10 over square root of 7 minus square root of 2. We cannot multiply them here. This is a hard one. I have to do something. That's why we make something, we called it the conjugates. When you multiply it now by, now if you have a square root of 7 times square root minus square root of 2, what is its conjugates? You have to write the same numbers, square root of 7 and square root of 2, but you have to put a plus sign between them. So if you have a minus, you have to put a plus sign between them. Then, since I multiplied the denominator, you have to multiply the numerator. Okay, is it clear?
Yes. Yes, miss.
Okay, then after that now, come to the denominator now. As I told you, if you have two conjugates, so the product of them will be the product, the square of the first term minus the square of the second term. Which is 7, and then the square root cancel the 7 is the square root cancel the squared, so we have 7 only, and the square root cancel the square root, so you take the number, this number only, which is 2, and so the final answer here, let's
It will be teacher 10 square root 14 over 5.
Yeah, so here first let's talk about the denominator here. We have 7 minus 2, which is 5. Now let's come back now to the numerator. To the numerator here, as you see, we have 10, and it's multiplied by square root of 7 plus square root of 2. So what we have to do? We have to multiply them like what we said yesterday by the distributive property. So we have to say it is 10 square root of 7 plus 10 square root of 2. Or in simplified one, keep them as 10 times square root of 7 plus square root of 2. Why? I will tell you, because I want to simplify it. That means I write it as 10 square root of 7 plus square root of 2 over 5 over the denominator here. Then after that, 5, here we have 2 after simplified. So we'd say them as 2 times square root of 7 plus square root of 2. Then after that, let's now multiply them. So we'll say they are 2 square root of 7 plus 2 square root of 2. So first, I look at the denominator here. In the denominator, as you see, what did we have? We have here we have a square root of 7 minus a square root of 2. This is not simplified. I want now to simplify it by cancel the square root in the denominator by using the way we call it rationalize the denominator. To rationalize the denominator, I have to multiply by the conjugates. These conjugates, that means this square root of 7 minus square root of 2, I have to multiply them by the same terms, but with different sign, like the opposite of them. Square root of 7, it stays square root of 7, minus, it will be plus, and the square root of 2, it stays square root of 2. And since you multiplied the denominator, you have to multiply the numerator. Then after that, as we said, let's come now to the denominator. What did we have? We have a square root of 7, take the square root of it, minus, take the square of the second square root. The square cancel the square root, so we have 7 only, and the square cancel the square root, so we have 2 only, so we have to write 5 in the numerator here. And then let's multiply 10 by square root of 7 and 10 by square root of 2. Or you can write them first like this to understand. It is 10 times square root of 7 plus square root of 2. Then as you see here, we have 5 in the denominator and 10 in the numerator. It can be simplified, is it right? It can be divided, 10 and 5. Divide by 5, divide by 5. So we have 2 times square root of 7 plus square root of 2. To multiply them, we have to use the distributive property. So we say it is 2 square root of 7 times 2 square root of 2. Is it clear?
Yes, teacher. Teacher, I have a question.
Yes, Farah.
Teacher, if I have like 81 over 16, a square root, any 81 square over 16, okay. How can I simplify it?
You
And
stop like
teacher, when
related to this example or another example here? You mean like this only? You have a square root of
yes.
18 of 16 over square root of 81.
No, the يعني 81 above 16.
Okay, it's square root of 81 over square root of 16. What is the square root of 81?
9.
And of 16?
4.
4. Right, we have to
This
stop here.
teacher, this is only?
Yes.
I will not
Is there any
simplify
common
more.
number that if you multiply them, if you I mean like if you divide them by the same, you can simplify it? No. You cannot
okay.
simplify this one.
Okay, teacher, thank you so much.
Yeah, let's continue now. Or let's do this example here now. Here we have the sum. Negative 3 over square root of 10 plus square root of 5. As we see here, we have a square root on the denominator. So let's multiply now by square root of 10 plus square root of 5. What is its conjugates?
10 square root of 10 minus square root of 5.
Is it right?
Yes.
Okay, exactly. Thank you, Farah. Now then, since we multiply the denominator, we have to multiply the numerator with the same difference or with the same sum. Then after that, let's say in the numerator we have negative 3 times square root of 10 minus square root of 5. We multiply the numerator, and in the denominator we have to multiply the first square root minus the second square root, and I square it here. Then after that, let's look now at the denominator. Square root of 10 squared is what?
It will be 10.
It will cancel each other. It will be 10,
It's
exactly.
going to be 10.
And here, what did we have?
It's going to cancel each other, and it's going to be 5.
It will be 5 only, exactly. Now let's now come to the numerator here. In the numerator, what do we have to do? We have to use the distributive property. So let's say it is minus 3 times square root of 10 multiplied by minus 3 times negative square root of 5 times minus 3 times negative square root of 5. We say that negative times negative is positive. 3 square root of 5. Is it right?
Yes.
After we distribute them. Then let's now say it's negative 3 square root of 10 plus 3 square root of 5 over 5.
Teacher, how? And teacher, it's square root of 5. How, teacher, you made the sign?
Sorry?
Teacher,
yes, but
when you made, yes, when you multiplied -3 with the square root of negative 5.
no, here you have minus sign. It's minus 3 times minus -5.
Okay.
That's why we have plus. Is it clear?
Yes, teacher.
Yes, miss.
Teacher.
Let's do now these examples. 5 over square root of 2 minus 1. And then we have square root of 5 over 2 minus square root of 5. So 5 over square root of 2 minus 1. Now what is its conjugates? What do you have to write down?
Square root
of 2 plus 1.
Exactly. Square root of 2 plus 1. And up here, square root of 2 plus 1. Then after that, look, let's to the denominator now. Here, what we have to say? We say that it is the square of the first term minus the square of the second term. And then up, I will multiply 5 times square root of 2 plus 1. We multiply the numerators and we multiply the denominators. The product of the numerator we said it is 5 times square root of 2 plus 1, and of the denominator we have to multiply the conjugates, which we said before that it is the square of the first term minus the square of the second term. Then let's continue. Look at now the numerator. Let's say like it is 5 square root of 2.
Teacher,
Yes, Sarah.
here it is 5 over square root 2 square root minus 1 minus here square root 2 plus 1 over or multiply.
This is multiply, sorry. I write it as okay, thank you. So it is 5 square root of 2, then plus 5 times 1, which is 5, over square root of 2 squared. As we said, it cancels each other, so we have 2 minus 1 squared, which is 1. So we have 5 square root of 2 plus 5 over 1. Or you can remove the 1. So this is the final answer. Is it clear?
Teacher, what do you made 5? You multiplied by 1. So why you made plus square root of 5? The
sorry.
final answer.
Sorry.
Okay.
By mistake, wallah. It's like this. Is it clear now?
Yes, teacher.
Yes, miss.
Yeah, let's solve now number
Yeah.
33.
The 2 minus 1, where did it go?
It is 1.
Oh, okay.
I put them here as 1, then I remove it.
Okay, thank you.
And it's like this. Then you can say it is 5 square root of 2 plus 5. This is the final answer.
Thank you.
Okay, welcome. Yalla, let's do now number 33. I want you to help me. Okay? Yalla. 33. We have square root of 5 over 2 minus square root of 5. What we have to do first? We have to multiply it by what?
By
Fraction.
2 by 2
2
plus
minus
square root 5.
2 plus square root of 5. Exactly. And up
2 plus square root of 5. The same.
exactly. And 2 plus, yes, you have to multiply with the same. Bravo. Yalla then. In the numerator, what you have to write?
Square root of
Square
5
root of 5.
multiply 2 plus square root of 5.
Yes, so
I
you
know.
have to multiply the product of the first numerator with the product of the second numerator. Now let's multiply the denominators.
It will be
2 squared
2 squared.
square
No, minus.
2 squared.
Minus square root of 5.
Squared. Then let's continue. Square root of 5 times 2.
2 square root of 5.
Bravo.
2 square root of 5.
Plus square root of 5 times square root of 5.
That's 5.
Square
It
root
will
of
be
25.
It will be 5.
Which is, well, 5.
It will be 5.
Exactly, which is 5 over 2 squared
4. 4.
minus square root
Minus
of 5
5.
squared minus 5.
Oh.
Bravo.
Minus
5.
5.
So what we have to say then, it is 2 square root of 5 plus 5 over negative 1.
Negative 1.
We can write them as here as let's divide the first term by or at least let's change the signs. It will be negative 2 square root of 5 minus 5. Okay, since they are divided by, here I will tell you why. Since it's divided by negative 1, so you have to distribute the negative 1 into the two terms. 2 square root of 5 over negative 1, it will be negative 2 square root of 5. And 5 over negative 1, it will be negative 5. But if you keep them like this, it will be accepted. Is it clear now, number 33?
Yes, teacher. Yes, miss.
Yes, teacher.
Now let's take, this is for the conjugates. Let's take another example now for the multiplication. Okay, let's solve it before we finish our first period. Yeah, which one you want me to choose to solve it? 21, 24, or 27?
Teacher, 24.
24.
24, all of you?
Yes.
Yeah.
Yes, miss.
Yes, teacher. Yes, miss, this is 24.
Here we have negative square root of 12 times 4 minus 2 square root of 3. Yellow, what we have to do here?
Multiply negative
12.
square root of 12
Multiply
by 4 and
negative square root of 12 by 4 first.
And then by negative 2 square root of 3.
And then you multiply them by negative square root of, my negative 2 square root of 3. The first one, we have negative square root of 12. We multiply it by 4.
4, negative 2,
Yes.
negative 4,
Then,
and square root of 12.
so it is negative 4 square root of 12. Bravo.
But teacher, it must be simplified.
Yeah, but I
Factorize
will,
12.
yes, let's continue the second term first. It is negative square root of 12 times 2 negative square root of 3. So how it will be? It will be positive. Here you have
Yes.
negative square root of 12 minus negative 2 square root of 3. So we say negative minus negative is a plus. And then square root of 12 times 2 times square root of 3. We write 2 first, then we multiplied the square root. 3 times 12,
36.
36. So we combine them as square root of 36. Then after that, let's now continue. Now look at square root of 12. Is 12 is a prime number?
No, it's the composite
No.
of prime.
So let's now factorize it. It is 4 times 3. Is 3 and 4 are prime numbers?
No,
Yes,
no,
four.
only 4.
No,
Yes. Only 4.
only 3. So let's say that it is the square root of 12. It can be written as 4 times 3 plus 2. Now what is the square root of 36? It is a perfect square.
It's a 6.
It is a 6. Bravo. Now let's continue here.
It's a plus 2 square root of 36 or minus?
It's a plus because here we have minus times minus before. Here we have minus times minus. So it's plus.
Okay.
Yalla, then let's continue now in the second term here. So let's see, we have negative 4. Let's now distribute the square root into 4 and into 3. Plus 2 times 6, which is 12. Then, is it clear by now, as until now?
Yes.
Yes.
Yalla, then, square root of 4. What is the square root of it?
2.
2
2.
times minus 4 or negative 4, and the square root of 3. It cannot be simplified. Keep it as it is. Plus 12. Write them down. The negative 4 times 2.
Negative 8.
Negative 8
Negative 8.
times square root of 3 plus 12.
It's going to be 4 and the square root of 3, right?
No, here it's not the like radicals. We cannot add them. Here you have to stop here.
Oh, okay, sorry, teacher.
Okay, it's like negative 8x plus 9. Can you add them?
No.
Here we
No.
have the same. We cannot add them. Is it clear? What do you have now? Any question for this for number 24?
No, teacher, thank you.
No, miss. Thank you.
There's no question here?
No.
No.
Teacher.
No, there is no. No, thanks, teacher.